Today's lesson is called Solving Linear Quadratic Systems. So I'd like you to start with the opening exercise. It says, consider the system of equations shown below and graphed on the right. So the equations are there, already graphed for you, labeled so you can see which one is which. What are the solutions to the solutions to this linear quadratic system of equations, and how do you know? So please pause the video, try the opening exercise, and then resume the video to check your work. So now that you had a chance to try on your own, here is the answer to the opening exercise. What are the solutions? Should be 2, 3, and 7, 8. How do you know? These are the coordinates of the intersection points. So this is still a systems of equations, even though most of our experience with systems has been with two linear pieces. You can have a system that involves any type of function. So this is an example of a linear quadratic system. You have a straight line linear function piece, and you have a quadratic parabola curve piece. The answer to what's going to make both of them true is still going to be the points of intersection. So now let's move on and look at some examples. So example 1 says, solve the following system of equations graphically. So that means we must show our work for graphing, create a picture of each of these functions on the graph in order to identify the solution, which again would be the point or points where the two functions intersect. So we'll start with y equals 2x squared minus 7x plus 4. This is your quadratic piece, so you're definitely going to want to use a table of values and go directly to your graphing calculator. So on your graphing calculator, you'll go to the y equals screen, and you will type in 2x squared minus 7x, and then plus 4, and hit enter. In order to get a quick look at what that's going to look like, hit zoom 6 to graph it. So you can see there the basic idea. But we want to look at the table of values by doing second graph in order to get the very specific information that we need. So I'm going to start looking for the pattern. And what I do notice is that we're at 0, 4, we're going down. I see it going down to about -2, but then going back up to 1 and 8. However, I'm not seeing that symmetry piece that we're usually used to seeing. So we also have to figure out where the lowest point is. Since our A value is positive, we know that our parabola is opening up. We saw that on the graph. So we know that we have a minimum. So there's a couple different ways that you can go about doing this. The first one is to go back to the graph and calculate by hitting second trace your minimum, which would be number 3. It's going to ask you to go a little bit to the left of that and hit enter, to go to a little bit to the right of that and hit enter. And there you can see what my minimum is, 1.75 and -2.125. Now, we recently explored all the properties of symmetry of a parabola made from a quadratic graph. And we also discussed the axis of symmetry. The axis of symmetry cuts that parabola in half. And you can find that by doing x equals -b over 2a. Plugging in that x value to find your y value, and that also would give you that turning point. So I want to make note of both of those things on our notes. And now we also know we need to include this critical point in our table of values. So I'm going to do x and y. I will do the 0, 4, the 1, -1. Then we had 2, -2, but that's almost coming back on its swing back up. Because when we looked at our minimum, it actually happened at 1.75, -2.125, which is lower than -2. So we're going to put the 1.75 in here, -2.125. Then keep heading up on the x side to 2, with the -2, 3, 1, and 4, 8. So all of those points were in the table of values. The only one I really had to take a closer look at was that turning point. So underneath, let's put a couple of notes. You can calculate the min on your calculator by doing second, calc, and then number 3. Or you can use x equals -b over 2a for the axis of symmetry. That will give you your x value, which then will allow you to find your y value, which will allow you to find the turning point. So for all of this, I'll say to find the turning point. So that's critical for graphs that are not showing you that symmetry right from the start. So now we can go over to our graph and do the best we can to graph this. So 0, 4, 1, -1, no issues there. With the graph the size as it is, do the best you can to plot 1.75, which is 1 3/4, and then -2.125, which is going to be just a little bit below something like that. Then we've got 2, -2. We've got 3, 1. And we've got 4, 8. Then we'll create our picture by doing our smooth curve and labeling that with our equation, y equals 2x squared minus 7x plus 4. So there's the graph of our quadratic. Now this is a quadratic linear system. So we have our linear piece, which is y equals 11 minus 2x. Now, since it's a linear piece, you have choices. We can use our traditional y equals mx plus b work, meaning since this is in y equals mx plus b form, or basically close to it, because you could switch this to y equals -2x plus 11, our slope is -2, which I would write as a fraction. So we're going down and to the right, and we're starting at a y-intercept of 11. Or you can always make a table of values from the graphing calculator. So I do want to do that because we will need this information in just a minute. So let's go to our graphing calculator. I'm going to go to the y equals screen. I'm going to type in my second equation, which is 11 minus 2x, and hit enter. When I hit zoom 6, I'll now see both of them on the graph. And I can go second graph to look at my table of values for now y2, since I put it in the y2 position. So we'll copy some of those values, including the y-intercept, which is one of the critical points we know, onto our notes. So we'll do just a few here: 0, 11, 1, 9, 2, 7, and 3, 5. Now, the table of values is going to come in handy in this particular situation because our graph only goes from -10 to 10, and our y-intercept is 11, which is off of the graph. So I'm actually going to skip 0, 11. I'm going to do 1, 9, 2, 7, 3, 5. And because I know the slope is down 2 to the right 1, I can continue to follow that pattern and then grab my ruler as my straight edge to get my graph. Make sure to place arrows on both ends and label with your equation y equals 11 minus 2x. So let's take a look at this a little bit closer. We know we're looking for the solution, so that's going to be where these cross. And I definitely can see they're crossing right here on the graph. And when I look at that, that is not a point that can easily be read. The other issue we have is I can see, since both are going upwards, that eventually somewhere up in this area, they will cross. But I have no idea where, given the picture that I have in front of me. So this is why being able to use your graphing calculator to do these things is so very important. As you can see in this problem, we needed it just to graph the quadratic. Then we needed it for the linear because my y-intercept didn't fit. Now I'm going to need it again because I cannot tell the exact location where they're crossing, and I know they're going to cross again somewhere off the grid. So we'll have to adjust the window like we've done in previous lessons, and we'll use our calculator to find the intersection, which you can see the directions for down here in the bottom corner. So those are the buttons that we're going to hit, but I will demonstrate that for you on the graphing calculator. If I go back to the picture of the graph we had, one of the intersection points is showing, but one is not. So we're going to have to change this window. Right now we're going from -10 to 10. So we want to go to window, and we want to make sure that our X scale, I think is fine. We want to change our Y scale, and make it so that we can see a little bit better. And the problem is we need to be higher than 10. So let's go 20 and see if that does it. When I go back to the graph, now I can see both intersection points. So just remember, you may have to change the window. When we hit zoom 6, it automatically goes -10 to 10, but then you can adjust the window from there to see more of the picture. So again, this allows me to see both points. So now we're going to calculate the intersection. So I'm going to hit second, trace, and when we do calculate for intersection, we're going to choose choice 5. So you want to go all the way over to the left of the first intersection point and hit enter for your first curve. Go to the right of that point, hit enter for your second. On your graphing calculator, it may be necessary to hit enter again for your guess, and the answer will show right up on your screen. X equals -1 and Y equals 13. So our first intersection point is -1, 13. And then we're going to do that exact same thing again to find our other intersection point. So second, trace, number 5 for intersect. This time we're going to go all the way over to this intersection point, go a little bit to the left of that point, go a little bit to the right of that point. Again, you'll have to hit enter one more time, and then it should give you your answer, which is 3.5, 4. So that's crossing at an X value of 3.5 and a Y value of 4. So now we can write both of those things down. So our solutions are -1, 13 and 3.5, 4. So let's make just a couple little notes in addition to what we already wrote down. You're going to have to adjust the window. And remember that you do that by literally hitting the window button, and then you can change your X scale or your Y scale, whatever you need to do in order to find the answer. So this example was really important to show you the critical value of your graphing calculator when doing this. Now that we've looked at some examples together, I'd like you to try this practice problem. So it says, consider the linear quadratic system shown below. You have your equations there. I would like you to solve the system graphically by graphing both equations on the grid provided. The line and parabola are known as tangent to one another because they intersect but do not cross one another. So I want you to do that, and then I want you to answer the closure question. How many different possibilities are there for the number of solutions to a linear quadratic system? Make sketches of each of them. So you could write your type of solution with a sketch right next to it. At this time, I'd like you to pause the video, work on these two problems, and then resume the video to check your answers. Okay, let's look at this together now that you had a chance to try. If you're going to solve this system graphically, the first equation is linear, y equals mx plus b form, so you have y equals 2x minus 4. You can do that one of two ways. You see that on the left side of the paper in red. You can use m and b, and you must write down those two values for full credit for work, or you can provide a table of values that you get from your graphing calculator. For the second equation, it is a quadratic function, or quadratic equation. So you have y equals x squared minus 4x plus 5. That should have been typed into your graphing calculator. To get a table of values, make sure that vertex is in the center and you show the symmetry. So then when you do that, you can see that they intersect just at the one point. That's what we mean by tangent, and you see that both are labeled. So your solution here is 3, 2. And then as far as how many different possibilities are there for the number of solutions to a linear quadratic system, you're going to make sketches of each. So you can have 2 solutions where it crosses twice, 1 solution like you just saw with the tangent example or practice problem that you did. And then of course you could have no solutions where they don't run into each other at all. So make sure you've corrected your work and definitely make sure you get down these 3 options for solutions because of course that could be asked of you at any time along with the other information we learned today. And that concludes our lesson on solving linear quadratic systems, day 1.